Alright, another day, another problem. So we have here a simple thermodynamic problem and let's solve it right away. Basahin natin ang problem. Electric power is to be generated by installing a hydraulic turbine generator at a site 120 meters below the free surface of a large water reservoir that can supply water at a rate of 1,500 kilograms per second steadily. We are asked to determine the power generation potential in kilowatts. So, the first thing to do is to write what's given. Ang given sa atin is, for this particular problem, mas maganda na i-drawing natin siya para ma-visualize natin kung ano yung sinasabi or dinidescribe ng problem. What scenario? So, meron daw tayong kailangan nating mag-produce ng electricity. Mag-install tayo ng hydraulic turbine 120 meters below the free surface of a large water reservoir. So, may body of water dito or water reservoir in this particular case. And we are also given 1,500 kilogram per second. So, that is mass per unit time. That is mass flow rate. So, we're given mass flow rate. Our mass flow rate is 1,500 kilogram per second. And we are required to find power generation in kilowatts. Now, as you can see from this problem, we are only given two parameters, which is elevation and mass flow rate. Makikita agad natin that since there is an elevation and there is mass present, mass flow rate present, the energy involved is potential energy. And we know that the formula for potential energy ay ano? Remember that potential energy is equal to mass times gravitational acceleration times the elevation. But since we need power, it should be per unit time, how fast energy is being transferred. So, if that's per unit time, we will have potential energy in rate form is equal to the mass flow rate times the gravitational acceleration times the elevation. So, we will simply input our values using this formula. And doing that, what are we given? Mass flow rate natin ay 1,500 kilogram per second. Our gravitational acceleration, again in thermodynamics, we will use the value of 9.8066 meter per second squared. And z, which is the elevation, 120 meters. Yan. In thermodynamics, you must also be familiar with basic unit conversions. So take note that 1 Newton is 1 kilogram meter per second squared. So as you can see, kilogram times meter per second squared, that is equivalent to 1 Newton. So magpapalitan yung units natin kasi there is an equivalent other unit. So, pressing this into your calculator first, 15 times 9.8066 times 120. What will we get? So, 15 times 9.8066 times 120, that is 1,765,188. And our resulting unit will be Newton, kasi Newton to. This is Newton. Let's write it in a different color. Si kilogram times meter per second squared is equivalent to 1 Newton. So, ang mangyayari, we will have Newton, matitira si meter, over itong natirang second dito. And you must also remember, take note that, ano pang kailangan tandaan? 1 joule is the unit of energy as well as Newton meter. 1 joule is equal to 1 Newton meter. So, kung 1 joule daw ay equivalent sa 1 Newton meter, ibig sabihin itong Newton meter dito, pwede natin gawing joule. Alright, so proceeding, the value stays the same, 1765188, and the unit will now become joule per second. This is energy. Joule is the unit of energy, and second is a unit of time. Makikita natin na tama na yung units natin because power is energy per unit time. So, but again, di pa tayo tapos. We need to convert it to kilowatts. And remember that 1 watt is a unit, the unit of power. So, 1 watt is equal to 1 joule per second. So, ibig sabihin, ito pala ay equal sa 1 watt. So, we will have 1765188 watts. But we need to convert it to kilowatts because that's what the problem is asking for. So, you simply divide that by 1000 kasi 1 kilowatt is equal to 1000 watts. And our final answer will be the power in kilowatts is equal to 176.188 kilowatts. This is our final answer for this problem. Makikita natin na napakahalaga ng units in thermodynamics. So, take note of this simple conversions. These are all in the SI system. For this problem, we are asked to determine the specific kinetic energy of a mass whose velocity is 100 feet per second in BTU per pound mass. So, hinahanap sa atin yung specific kinetic energy. And when we say specific, again, it's per unit mass. So, kaya mapapansin nyo, this is energy per unit mass. British thermal unit per pound mass. So, what are we given? Iisa lang naman yung given sa atin, which is velocity. The given velocity is 100 feet per second. So, let's proceed. We know that kinetic energy has the formula 1/2 mass times velocity squared. But we are asked to find the specific kinetic energy. So, we simply divide it by mass kasi it's per unit mass. So, what will happen? Shing, cancel lang yung mass. So, ano matitirang formula? So, we will have 1/2 times velocity squared. So, using this formula, we can get the specific kinetic energy. So, let's proceed. So, again, kapag specific kinetic energy, this should be written in small letters. So, our specific kinetic energy is equal to 1/2 times the velocity squared. So, proceeding, let's write what we have. 1/2 times our velocity, 100 feet per second, and that is squared. So, distributing square to the unit and to the numerical value or the magnitude of the velocity, we will have 100. 100 squared is equal to 10,000. And this will become, the unit will be feet squared per second squared. So, in thermodynamics, kailangan maingat talaga sa units. Yeah. And so, 10,000 times 1/2, that is 5,000 feet squared per second squared. But, mind you, sa problem, tinatanong sa atin is the specific kinetic energy, dapat ang unit daw is BTU per pound mass. So, how will we do that? So, lipat lang natin dito. Diretso natin dito pala. So, our kinetic energy is 5,000 feet squared per second squared. To convert that to BTU per pound mass, pwede muna tayong dumaan sa foot-pound force. Kasi foot-pound force or pound-foot is also a unit of energy. And we know, note, that 1 BTU is equal to 778 foot-pounds force. Yeah. So, kailangan dumaan muna tayo sa foot-pound force para ma-convert natin siya sa BTU. And we need also yung unit ng mass na pound mass. So, ang pwede natin gawin, we can multiply it to the factor. Remember that to generate 1 pound of force, let's make it blue. 1 pound of force, we need 1 slug times feet per second squared. But kailangan natin is a pound mass, so we will just convert slug to pound mass. And we know that 1 slug is equal to 32.174 pound mass times feet per second squared. So we can use this factor. And multiplying this by this factor, we have 1 pound force over 32.174. This is the same as the gravitational acceleration in the English units. Yeah, so 1 pound force is equal to 32.174 pound mass feet per second squared. And from here, you can see na this will cancel out. Shing, shing. May matitirang isang unit ng feet doon. And then, tataas to dito. Tapos magka-cancel out yung second squared. And we will be left with, but pressing that into your calculator, 5,000 divide 32.174, that is equal to, let's use 4 decimal places. Pero in your calculator, you must shift store to maintain accuracy. So, pag pinindot 5,000 divide 32.174, that is 155.4050. Ang matitirang unit is may isang foot, tas pound force all over pound mass. So, you're on the right track. All over pound mass. And since we've arrived with this energy per unit mass, we're on the right direction. Kailangan na lang natin i-convert itong foot-pounds of force to BTU. And we can use this conversion. Kailangan lang i-memorize at tandaan. Take note that 1 BTU is equal to 778 foot-pounds of force. So, multiplying that, converting the unit, 1 BTU is equal to 778 foot-pounds of force. Ayan. So, the units will cancel out. Shing, shing. And pressing that your calculator, na naka-shift star yung value, 155.4050 divide 778, you will have 0.4 decimal places, 1997. And again, ang natirang unit is yung hinahanap sa problem na BTU per pound mass. Pag magaling ka sa conversion at sa ulo mo lahat ng mga necessary conversions, unit conversions, hindi ka maliligaw sa thermodynamics. So, our final answer would be the specific kinetic energy required is 0.1997 BTU per pound mass. This is the final answer for this problem. For this other problem, we are also asked to find the specific kinetic energy of a mass whose velocity is 30 meters per second in kilojoules per kilogram. Katulad lang to ng previous problem. But in this case, we are in the SI units kasi kanina we are in the English units. So, what are we given? We are given a velocity of 30 meters per second. So, again, the formula for specific kinetic energy is simply 1/2 times velocity squared. So, plugging our values to this formula, the kinetic energy is equal to 1/2 times our velocity, 30 meter per second squared. So, pressing that into your calculator, kinetic 1/2 times 30 squared, that is 450. The unit will be meter squared per second squared. And katulad ng ginawa natin kanina, we need to multiply it to the factor of, take note of this, we know that 1 Newton of force is equal to 1 kilogram times meter per second squared. So we can use this factor in converting this to joules per kilogram. So proceeding, we will have 450 meters squared per second squared and multiply to the factor of 1 Newton over kilogram times meter per second squared. So, ano mangyayari? This is just a matter of unit analysis. Again, master the basic units. Hindi ka maliligaw sa thermodynamics. Kailangan mo lang silang tandaan at marunong ka dapat sa basic algebra and unit conversion. So, this will cancel. May matitirang isa. And, again, tong second squared ay pupunta dito sa numerator. Magka-cancel sila. Shing! Shing, shing, shing! So, ang matitira na units natin is 450 Newton meter per kilogram. And from our first problem, 1 Newton meter is equal to 1 joule. So we have here 450 joules per kilogram. But it is required na gawin natin siyang kilojoules. So, simply, we will divide it by 1,000 kasi 1 kilojoule is equal to 1,000 joules. It's just because of the prefix kilo kasi kilo is 10 raised to 3. So, pressing that into your calculator, our specific internal kinetic energy for this particular problem is 0.45 kilojoules per kilogram. This is the final answer for this problem. Now, for this problem, we are asked to calculate the total potential energy in BTU, or British Thermal Unit, of an object that is 20 feet below a datum level at a location where G, or gravitational acceleration, is equal to 31.7 feet per second squared, and which has a mass of 100 pound mass. So, let's proceed. First, let's write what are we given. Given sa atin is yung elevation. Pag sinabi nating datum, this is just a reference point. A reference point, yeah. So, let's draw it again para mas ma-visualize natin. Ang energy present again dito, since elevation is involved, is potential energy. So, we have here 20 feet yung elevation natin from this point up to this point. And the gravitational acceleration is given. Hindi siya yung standard gravitational acceleration na ginagamit natin. So, G is equal to 31.7 feet per second squared. And the mass is also given. Mass is equal to 100 pound mass. We are asked to calculate the total potential energy. So, ano nga ba ang formula for potential energy? Simply, potential energy is equal to the mass times the gravitational acceleration times the elevation. we will simply plug our values into this formula. So, for potential energy is equal to, ano yung mass natin? 100 pound mass times the gravitational acceleration. Gravitational acceleration is equal to 31.7 feet per second squared. And our elevation is 20 feet. This is just a matter of unit analysis. So, what will we do? Una natin gagawin is, let's press this first into our calculator para mas madali tayo makapag-analyze ng units. So, pressing this into your calculator, 100 times 31.7 times 20, you'll have the value of 63,400. And the units will just multiply. So, multiply lang natin. So, meron tayo ditong pound mass. Feet times feet is feet per second squared. Feet squared. And may natirang second squared sa baba. So, what will we do now? So, we will just use again the conversion na 1 pounds of force is equal to 32.174 pound mass feet per second squared. Para makancel natin yung necessary units at magawa natin siyang British thermal unit. So, doing that, 1 pound of force is equal to 32.174 pound mass feet per second squared. Yun. So, using that factor, makakancel natin yung mga units na dapat makancel. So, shing, may natirang isang feet. And again, itong second squared, since nasa denominator, tataas to dito sa numerator and this will cancel. Shing. Anong natira? Ito pa pala. Pound mass. Tanggal din yung pound mass. Ang matitira is may isang feet at pound force. So, 63,000 times 400, 63,400 divided by 32.174 is equal to, pressing that into your calculator, 63,400 divided by 32.174 is equal to 1970.5352. And shift storing that value into your calculator in whatever variable, ang unit nito is foot-pounds of force. Ito ay unit ng energy, but we need to convert that to BTU. Again, take note that 1 British thermal unit is equal to 778 foot-pound force. So, using that conversion, 1 BTU is equal to 778 foot-pound of force. And pressing that into your calculator, our total potential energy in British thermal unit is equal to 2.5328 BTU. And this is our final answer. Again, kailangan lang natin tandaan yung mga factors and conversions to be able to solve problems regarding energy, alright, and thermodynamics.